So today we have a bonus video. I received a question from one of my viewers on how to do a 2.5D map. And so it functions like a 2D map, but it has depth and visually looks 3D. Now you cannot move back into the blue and the green areas. You have to stay on the brown, but you, like I said, get the benefit of the visual side of 3D opposed to just having to have different sprites and parallax backgrounds. And so how we accomplish this is we just have a spatial node and a grid map, which I made a fresh mesh library, even though it looks very similar to some of my other tutorials. And the reason why is I just wanted to have everything be 1 by 1 by 1. So this grid map is 1 by 1 by 1. You'll have to make mesh library that has cubes that are 1 by 1 by 1. And just know that when you make a mesh instance and you add a shape to it, the default usually is 2 by 2 by 2. So just make sure that you update that, and then you add a color, you make a mesh library, and then we will actually procedurally add everything in the script. So this camera I added just to help see and debug my script for actually making the map. It's not actually used in the final product. I have a camera on the player, which we'll go over, but like I said, this camera, I'll show you the script. Just look at the orientation of the axes. I also had to rotate the camera around 180 degrees to get the right visual look for debugging. Now, on the player, I just have a kinematic body with a mesh instance and a camera. And again, you want to have along this blue axis, you want to move it farther back. And I actually just moved the camera up and pointed it down a little bit just to so you could see the 3D-ness of this project a little bit better. In the script, this is just a very basic movement. This isn't what you would probably end up with in the end. You'd add some type of more platformer-friendly movement with some gravity, but this is just a tutorial on how to actually make the map, so we'll focus on that more right now. So we'll go to the world script. We are going to add the player procedurally, so we need a reference to that scene. We're going to reference the map, and we're also going to use a 3D noise, open simplex noise, to generate the core of the map and all the caverns, because the person that requested this wanted to have a cave-like structure. So we're going to have the map size, and like I said, this is kind of like a 2D game, so the bulk of the map is going to just be the height and the width, and then it's only going to have 4 layers of depth because those are just for visual effects. Now in the ready function, I've done this before in other tutorials, but we have an open simplex noise, and it's going to be a very unrefined noise, and it's going to be not zoomed in very far. The lower the number of the period, the less zoom there is on the noise. So first we're going to make the map, and then we are going to place the player. So when we make the map, we're going to add some borders, that way you don't just fall out of the map. So we're going to set all of the background to a certain color. And the difference between these for loops is very important. In Godot, when you have a for loop like this, it will start at 0 and it'll go to the number before width. So to show an example, so here I have depth for z and depth, and here I have for z and depth. But this one is in an array, and it treats it very differently than this z and depth. So this, if you recall, our depth is 4. So this is the array is only going to loop through once, and z will be 4 because it's an array. It only does one. It just does that one number. Now this z in depth, it's going to start at 0 and loop through 0, 1, 2, 3. It will not loop through 4. So that's how we get the background to be all one color. Now we're also going to set the floor and the ceiling. And this, again, we're going to use an array. And the height is the same thing that I just got done talking about. It's going to be outside of our main loop for the caverns because it is treated differently in an array than it is in just a typical loop like this. And we have to go to -1 because this loop will start at 0. So we will set all of these to the rock, and that's just the darker one. And again, for a third time, the sides, same story with the width. So to make the caverns, we're actually going to use the 3D noise. So we will loop through the entirety of the map, and we will set a final variable to what we want the color to be. So we will check the 3D noise at each spot in the grid map. We will check to see if it's lower than this number. Now this number usually has to be pretty small. Most of the numbers kind of gravitate towards lower numbers in 3D noises. And if it is lower than this number, we will set it to -1. So if you use the set cell item and set it to a negative number, usually -1, it will delete that cell. And otherwise, we will actually use Z. And the reason why that works is, remember, Z is only going to be 0 through 4 or 0 through 3 because we're looping through the depth, and the depth is 4, but we do not loop through on 4. And when we go to our mesh library, we have the options of 0, 1, 2, and 3. Those are all the different colors that we have. So when we set it to that, we'll get a different color for each layer. Now, placing the player is very simple. We just loop through the first layer. We're going to always have Z be 0 because we want the player to be at the layer closest to the camera. And we will get the cell item to check it, and if it is empty, remember -1, we will make a player instance, and we will set its transform origin, kind of its position, to the map to world coordinates. So what map to world function does, it's a built-in function for grid maps. It can take a grid coordinate and turn it to a global coordinate. So we can place the player in the proper spot. And then we'll add that child. One of the most important things you cannot forget is to return. If you do not return, it will fill every single empty spot in your map with a player instance. So do not forget the return. And what we end up with is a little square that can move around, and hopefully this looks pretty cool. And like most of my tutorials, this is just a tutorial to get you started on what is possible and could use a lot of refinement, but I think it looks pretty cool.